IBHL Math Masters Strategies. In this video, we are going to take three examples and see how do we work with the sigma notation. Sigma, as you know, is used for summing up a series. The question here is if A and R are two real numbers, we know that sum of the series from k equals to 0 to k equals to n for AR to the power of k is given by the formula A times 1 minus r to the power of n plus 1 divided by 1 minus r. Knowing this formula, we need to find the sum of A, B, and C. What you notice here is that the summation is from the lower and the upper bound has been changed, right? So we need to understand what really happens when we change the summation upper and lower bounds. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are doing extremely well, joining the best universities and even with scholarship. This question comes from one of my students who wants to understand simple way of answering this type of question. And therefore, we are going to get into details of understanding what the sigma notation is and how do we quickly get to the answer. So let's go the long way, getting the concepts clear. So when I write that we have the sum of a series which is A r to the power of k, and the series is from k equals to 0 to n, it really means that we are going to substitute different values of k, so it becomes a r to the power of 0 plus a r to the power of 1 plus a r to the power of 2 plus a r cube plus so on till a r to the power of n. You can clearly see that this is a geometric series, right? Where the initial term is a and it is being multiplied by r each time, and therefore the sum of the series we know the formula. So that is the starting point. Great. Now, what we need to do is to find what happens when I change k value from 0 to 1, right? Or the n value from n to n minus 1. Definitely, we are reducing the number of terms in these cases, and therefore the sum is going to get reduced. Perfect. Keeping that in mind, I'd like you to now pause the video, answer, and then look into my suggestions. And do not forget to check the end, where we are also sharing with you a tip to verify that your answer is perfectly fine. Great. So let's begin with the very first part, which is we need to find what is the sum of this particular series when we are taking k from 1 to n instead of 0 to n, right? Of a r to the power of k. Now, definitely, if you are taking from 1 to n, that means we could actually use the formula given to us where k is from 0 to n, right? For a r to the power of k, and we can subtract when k was 0. So k was 0 means a r to the power of 0. Perfect. So that really means that the formula given can be now used, and therefore for the first term, which is sigma 0 to n, we can use the formula. Rewriting the formula, which is a 1 minus r to the power of n plus 1 divided by 1 minus r. And we have to take away the first term, which is a, right? Anything to the power of 0, as you know, is 1. So that is simple as that. Now, this brings us to a common denominator of 1 minus r, and we can write a, let's open this bracket, minus a r to the power of n plus 1 minus a times 1 minus r. Let us expand and write the expression. We get a minus a r to the power of n plus 1 minus a plus ar, correct? Over 1 minus r. Now, as you can see, a and minus a will cancel, and therefore what remains is minus ar to the power of n plus 1 plus ar, correct? Divided by 1 minus r. Taking r common and a common, right? A and r is common. Then this term is 1 minus what remains here is n plus 1 minus 1. So 1 minus r to the power of n, right? N plus 1 minus 1 will give us this. Divided by 1 minus r. Do you see? So we have a formula. It will be ar into 1 minus r to the power of n divided by 1 minus r. Perfect. Simple. So I hope you have understood this strategy. Apply this strategy and get the solution for the next one. Now, in this second example, what we are doing is we are trying to find the sum of the series where k goes from 0 to not n but n minus 1 for a r to the power of k. So clearly the last term is not being added, rest all are being added. Perfect. So this could be written as the sum of the series from k equals to 0 to n, right, of ar to the power of k minus the last term where k is n, right? So which is a r to the power of n. Makes sense. Now we know the formula for the first term. Utilizing the formula of geometric series for sum of n terms, we get a 1 minus r to the power of n plus 1 over 1 minus r minus a r to the power of n. Makes sense, right? Let's continue to simplify this particular expression. So what we get here is now taking common denominator, which indeed is 1 minus r, right? Open this bracket as we did earlier, a r to the power of n plus 1, multiply minus a r to the power of n times 1 minus r with common denominator. Expand and simplify to get the result. So we have a minus a r to the power of n plus 1 minus a r to the power of n, and here we get plus a r to the power of n plus 1 divided by 1 minus r. So you see this time these terms will cancel, correct? Perfect. So what we are left with is basically equal to a is common, right? 1 minus r to the power of n over 1 minus r. Makes sense. So that becomes the sum of this particular series. So with that, we've done two of them. And now let's do the last. So I hope the concept is absolutely clear, right? With that, let's now get the solution for the last one where we are looking for the sum which goes from k equals to 1 to n minus 1 for the series a r to the power of k. Now, last time, what did we do? We can use that result, correct? It was from 0 to n minus 1, which is a times this, right? So this time we'll use that and we say, well, this is equal to k from 0 to n minus 1, right? A r to the power of k, subtract the last term. Perfect. So since subtract the first term, right, which is the 0th term, so which is minus a, correct? R to the power of 0, let me rewrite. Perfect. Now, what was the sum which we get? Well, for the first term, we got a sum which was 1 minus r in the denominator remained as such, right? And what happened in the numerator? Numerator was a times 1 minus r to the power of n. Perfect. And from here, we are going to take away a. And now we are going to simplify as we did in first part. So let's open this bracket, a minus a to the power of a times r to the power of n minus a times 1 minus r divided by 1 minus r. That gives us a minus a r to the power of n minus a plus a r over 1 minus r. And that gives you the solution, which is a and minus a cancels. We can take a r as common, correct? Taking a r as common, we get 1 minus r to the power of n minus 1 over 1 minus r. Makes sense. So that becomes the final result. Now, it is time to understand how we could relate all our formulae, right? Since here you can see the simple change is that instead of the lower bound being 0, we have it as 1. And the result is that we are multiplying the numerator by r and reducing the power by 1. You get the idea. So when you reduce one term, especially the lower limit, in that case, the power reduces by 1 and a gets multiplied with r, correct? Let's see if that rule works for the first case. Hey, yes, it works. R is being multiplied here, right? So we can now write down the solutions which we really got. So for the first one, right, we got a formula which was equal to a times r, and since one term was reduced, we have 1 minus r to the power of n over 1 minus r. You see that? So that was the result when we reduced one term right in the beginning. Perfect. Now, what happens when we reduce the upper limit? That means one power is less on the upper limit. So let's look at it once again. So answer was, since we reduce the upper limit by n minus 1 in the formula, the power n plus 1 reduced by 1. Clear? So that was quite simple. So what we did here was, let me just write down a line here showing this was this one. And for that, we have a 1 minus r to the power of n. Since last term is now n minus 1, so you just replace n with n minus 1 to get the result, right? 1 minus r. Does make sense to you, right? And now, can you write down what happens in this particular case? Since we are not using the first term, what we are going to do is multiply the previous result by r, right? So let's do it. So we have a times r, and then we'll reduce this power by 1, right? Since we are using n minus 1 terms and 1 minus r. Do you see the summary? How quickly we got to the right result, saving all the time of simplification. Perfect. So changing the limits of the summation is not very hard to work with. Perfect. Have a good look at it and then see the final solution to really understand what is the expected result of these changes in lower and upper bound of the summation. I hope it all makes sense. Feel free to join my classes by sending an email to globalmathinstitute@gmail.com. Understand the concepts and do extremely well. Thanks for your time and all the best.